When one number decreases in value, this change can be represented as a number, a fractional decrease, or a percent decrease. In this video, we'll look at examples of numerical decreases in value and see how this corresponds to a percent decrease. Let's look at an example. A sweater that originally sold for $50 was reduced to $36 for a closeout sale. What was the percent decrease to the original cost of the sweater? In this situation, there is a reduction in price, and we can find the percent decrease by using this formula. This formula takes the fractional decrease in price and multiplies it by 100%. We plug in values from the scenario. In the numerator, we subtract 50 from 36. The resulting fraction is negative 14 over 50. After multiplying by 100%, the result is negative 28%. The negative sign indicates a percent decrease. Let's look at another example. An SUV was purchased new for $24,750. After a year, the trade-in value of the car was $20,047.50. What was the percent change in the price of the SUV? In this example, we want to calculate the percent decrease in the price of a car. This is an example of what's called depreciation, where the dollar value of an item decreases over time. To calculate the percent decrease, use this formula. Plug in the given values into the equation. This is the new price of the car, and this is the original price. The numerator is divided by the original price. This is the simplified fraction. The result is negative 19%. The negative sign confirms this is a percent decrease. Let's look at a final example. A cube's side lengths are decreased from 5 to 4.25. What is the percent decrease of the surface area and volume? The decrease in the side lengths of a cube have a corresponding decrease in the surface area and volume of the original cube. These are the formulas for surface area and volume. We will use these formulas to find the percent change in the cube. Let's start with the surface area. Here are the values for the surface area for each cube. We take those values and plug them into the percent change formula. This is the new value. This is the original value. And the denominator also has the original value. This is the fractional amount, which simplifies to negative 27.75%. Now let's look at the change in volume. These are the values for the volume for each cube. Let's plug these into the percent change formula. This is the new value. This is the original value. And the denominator also has the original value. This is the fractional amount, which simplifies to negative 38.5875%. You can see that a small change in the length of the side of the cube results in a dramatic increase in volume. In fact, the volume is less than half the original volume. This graphic summarizes the percent decrease in the side length, surface area, and volume. Since length is a linear measure, it shows the least percent decrease. Surface area, which is a nonlinear square measure, shows the next lowest decrease. Volume, which is a cubic measure, shows the greatest percent decrease.